dear students, welcome to physics classes. So in the previous lecture we have done the force mechanical oscillator and the steady state behavior. Okay? So now we will discuss first transient behavior, then velocity and acceleration. So first is transient behavior. Transient behavior, you know that the equation of motion that we have done in the previous article, that m double derivative of x with respect to t square plus sx plus r and first derivative of x with respect to t, that is equal to f naught e raised to power iota omega t. So this is the equation of motion for a force mechanical oscillator. And in the steady state behavior, we have the oscillator is under the effect of force and its natural frequency dies. But in transient behavior, it is oscillating with its natural frequency and this force is equal to 0. So if this force is equal to 0, then this is just like the damped mechanical oscillator. We have done 3 cases in over damping, light damping and critical damping. So the same procedure will adopted by you in this you can say transient behavior, and the solution will come. I will write here, repeat here only the solution. You can go to that lecture. So x is equal to e raised to power minus bt a1 e raised to power under root of b square minus omega naught square t plus a2 e raised to power b square minus omega naught square with minus sign into t. So I think this is the solution of that here. And then cases arises for heavy damping, b square is greater than omega naught square. For critical damping, b square is approximately equal to omega naught square, and for light damping, b square is less than omega naught square. And after at the last you will get the value of frequency, that is s over m under root s over m minus r square over 4m square. This will be the frequency of damped mechanical oscillator. Same the electrical that we have already done. So this is about the transient behavior, same like the previous lecture. Yeah. Now we will do in this lecture that I missed in the previous lecture. That's why I explain it. Then our main is that is the velocity. That is the velocity for a force mechanical oscillator. Velocity for force mechanical oscillator. Yes, beta. Velocity. So we have done displacement. So what is the value? I have already told you in the previous lectures that you must remember this value, because this value is used in the next articles. X is equal to f naught minus iota f naught e raised to power iota omega t minus phi divided by omega zm. So this is our value, minus iota f naught e raised to power iota omega t minus phi over omega zm. So you can real part of x is equal to f naught over omega zm sin, that we have also done here, and real part of force f is equal to f naught cos of omega t. Now we want velocity. So to find out velocity, what to do? Differentiate this with respect to t. So differentiate this with respect to t. What you get? Minus iota f naught over omega zm. The derivative of e raised to power is e raised to power, same. And what is multiplied? Here the constant, the terms. Yes, phi is constant, iota omega. So iota omega is minus iota omega. Iota is here, iota square is minus 1, and minus 1 with minus 1 goes positive. So the final solution is omega f naught and omega f naught over omega zm e raised to power iota omega t minus phi. So this is omega goes with omega, or you have f naught over zm e raised to power iota omega t minus phi. This is, that is velocity. That is velocity. So this is velocity. Yes, only f naught over zm, no iota here, as in the case of x, e raised to iota omega t minus phi. So from this, what you conclude? Now what is the phase difference between velocity and force? That is phi. That is phi. So the phase difference between velocity and force, that is phi. That is phi. Clear? Now you can also find velocity, magnitude of velocity from this also. So if you find from this, differentiate this. This is equal to, that is equal to v, that is equal to real f naught zm cos of omega t minus phi, and multiplied by derivative of sine is cos, and omega comes out here. So that is equal to f naught over zm cos of omega t minus, in terms of cos of sine. You have velocity this. In vector form you have this. Okay. Then you can also simplify this. How can you simplify this? You can simplify this like this. Yes, I simplify this here. Can I write it? Velocity is equal to f naught over zm e raised to power iota omega t. I separate these, and into e raised to power minus iota phi. E raised to power iota omega t, e raised to power minus iota phi. I separate these. When I separate these, can I write it as like this? F naught e raised to power iota omega t divided by zm e raised to power iota phi. And what is f naught e raised to power iota omega t? That is force in vector form f, and zm e raised to power iota phi, that is equal to zm in vector form. So this is also velocity. So velocity is also equal to the ratio of force and mechanical impedance. So this also comes in short answer type question, that define velocity in terms of impedance. So you can say that it is a ratio of force and mechanical impedance. So this is also velocity. Next is acceleration. Next is acceleration. Yes. Next is acceleration. How can you find acceleration? Yes. Right here, acceleration. Acceleration for force mechanical oscillator. Yes, you have velocity. If you have displacement, you can differentiate it with respect to t, you will get velocity. And if you differentiate velocity, you will get acceleration. So differentiate velocity with respect to t, you will get acceleration. So acceleration is equal to derivative of v with respect to t. That is equal to derivative of f naught over zm e raised to power iota omega t. Then I again combine it. Yeah. And what is then? Yes. Derivative of this f naught over zm outside e raised to power iota omega t minus phi. And what is iota omega here? Iota omega here. So this is our acceleration. This is our acceleration. Clear? So this is acceleration. You can also find the real part of this acceleration by putting the values of e raised power, or you can only write here velocity is equal to, I can write velocity is equal to f naught over zm cos of omega t minus phi plus iota sine of omega t minus phi. So when you get the real part, that is equal to f naught over zm cos of omega t minus phi. So this is real part. So when you differentiate it, it is acceleration, and acceleration is equal to f naught over zm, the cos sine of omega t minus phi cos the minus sign minus, and what is multiplied by omega. So minus f naught over omega sine of omega t minus phi. This is in magnitude form. So this is acceleration. Now what is the phase difference between acceleration and force? Iota pi by 2. Here is phi, so pi by 2 plus phi. So this is the phase difference between acceleration and force. So this is all about velocity acceleration. So in the next lecture we will discuss about the variation of displacement with frequency, driving force frequency, with which frequency the force oscillator is going to be driven. Okay, and the velocity with omega, and also acceleration with omega. Thank you very much. So go through this.